I have a commit arm light. Mark 5 seconds and counting. Ignition.
This is the edge of space, a port for new voyages. Here, almost 30,000 military and civilian workers strive toward two goals: knowledge and great national strength. Nearly 1,600 major missile and space flights have been launched from these pads since 1950. This is the story of the past year. In 1964, the United States got its first close-up pictures of the moon with this spacecraft. Two missile systems completed rugged research and development test flight programs. A communications satellite launched from here brought America live television of the Tokyo Olympics. And preparations were made for the manned Gemini flights scheduled for early 1965. In the development of ballistic missiles, the rapid pace established 10 years ago by General Bernard Schriever continues. Minuteman I, America's instant-reacting intercontinental ballistic missile, developed, flight-tested, manufactured, and deployed concurrently, completed its 54th and final test in September. More than 600 of the Boeing-built Minuteman missiles are now on duty with SAC in underground silos similar to this one on Test Complex 31. Before the Minuteman I program ended, a new and more powerful version of this missile, Minuteman II, entered the Cape test arena. A larger second stage supplies more power for a greater striking range. A new guidance package refines the already pinpoint accuracy, and a new high-capacity miniaturized computer provides the deadly weapon with a greater flexibility in target selection.
ATO switch to proceed. Proceed. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
While Minuteman continues its tests at the Cape, the Air Force's combat Minuteman force will ultimately grow to a total of 1,000. When missiles were added to SAC's bomber force, the nation's deterrent to war was strengthened. Another element, the nuclear submarine, gave this deterrent a new shape and dimension. Far beneath the surface of the world's oceans, United States Navy submarines carrying lethal, ready-for-launch Polaris missiles are on station, alert, ready to strike. This fleet was complemented in 1964 by the addition of the 2,800-mile range Polaris A-3 missile after extensive testing at Cape Kennedy. Missile, men, and submarine, before being strategically deployed with the fleet, must first come to the Cape and be proven in a test. More than 40 Polaris missiles were fired at the Cape during the year. Successful missile systems development has provided the technological basis for the push into space. The Air Force Titan best tells this story. In April, the 6555th Aerospace Test Wing completed the research tests of this continent-spanning giant, which develops more than 500,000 pounds of thrust. The Martin-built Titan uses hypergolic self-igniting propellants, giving it a quick reaction capability of being launched to targets more than 6,000 miles away. Titan II is on station with Strategic Air Command missile crews in hardened underground silos. Although developed as part of a weapons system, Titan II has been selected as the booster for NASA's new Man in Space program. Project Gemini. In 1964, Gemini began with the orbiting of an unmanned spacecraft as a test of the new booster spacecraft combination. An Air Force industry team, headed by Lieutenant Colonel John G. Albert, the Titan II Gemini launch director, prepares and launches the booster for NASA, the same role the Air Force played in the Mercury program. Manned missions will begin with the third flight in the series, scheduled in 1965. In October, President Johnson saw another phase of Gemini preparation. Astronauts Gus Grissom and John Young, who are scheduled for the first manned flight, were training in the capsule simulator in mission control. In the capsule, an exact replica of the Gemini spacecraft, every possible flight condition is simulated for the astronauts. Gemini missions will include orbital flights lasting up to 2 weeks. They will practice rendezvous and docking techniques with another spacecraft, and on some missions, one of the astronauts will actually leave his capsule and step out into space. A new Titan, the 3C, with 2 solid propellant boosters, is being readied for the Cape scene. A Titan II with an added third stage forms the core. The new rocket will be powerful enough to orbit a 12.5-ton payload into Earth orbit. The core's third stage, capable of stopping, restarting, and maneuvering in space, gives the Air Force a versatile standard booster to accomplish a variety of missions in space. To support the Titan III, a new concept for launch preparation was introduced. A complex where the rocket could be assembled and launched in minimum time. Major construction of this integrate transfer launch complex on man-made islands in the Banana River was completed in December. A main element of the ITL is the vertical integration building, where the core vehicle and spacecraft will be assembled vertically in one of 4 bays. The fully assembled core will be transferred on its launch platform to the solid motor assembly building, where 2 powerful solid propellant boosters will be attached to the core to form the 3C configuration. Each of the solid fuel boosters will provide 1 million pounds of thrust. The rocket and its spacecraft will then be moved on a special railway to one of the 2 launch pads. Designed for a fast turnaround and high launch rate, this system can support as many as 40 launches a year. Although the first Titan 3C launch is not scheduled until the spring of 1965, 2 Titan 3A core vehicles were test flown in 1964. These tests met with tight schedules established in 1962. Brigadier General Joseph Blaymeyer, who directs the fast-paced development program, moved through the countdown with the launch crew. He assessed the first test, which had excellent trans-stage performance but failed to orbit the payload, as 95% successful. The second flight in December put its 3,700-pound payload within 200 feet of the planned 100-mile-high orbit, and the trans-stage executed 2 intricate moves in space with split-second accuracy. Titan III is on schedule. While Titan III moved in military directions, the Saturn, NASA's giant liquid-fueled booster, passed 3 critical tests in 1964. These tests paved the way for development of a much larger and more powerful rocket for the Apollo lunar landing mission near the end of this decade. 14 weeks of preparation lead to a 17-hour-long countdown for launch. 1964 flights included tests to prove the structural integrity of the Apollo spacecraft and the reliability of a new hydrogen-fueled second stage. The giant first stage requires 850,000 pounds of propellant. Months of preparation have ended. Saturn stands on its launch pad, awaiting the signal that will unleash 1.5 million pounds of thrust. Countdown for each Saturn launch is involved and complicated. Information gathered at this time is vital, not only to the test at hand, but to the future.
In flight. Time-based selector on.
Time-based selector on.
Lockhouse measuring, verify 100 cycle oscillator on.
100 cycle oscillator on.
Program device on.
Program device on.
Command receiver number 1 on.
The director of the Marshall Space Flight Center, Dr. Wernher von Braun, plays an important role in this program, as does his longtime friend and colleague, Dr. Kurt Debus, director of NASA's Kennedy Space Center. Both these scientists have contributed their genius to the development of our country's space program.
T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0.
The amount of electronic and optical data acquired on a flight such as this is staggering. Every detail contributes to the success of the total program. No fact is insignificant. Long-range optical systems record separation of the first stage and ignition of the second. Special cameras on board the Saturn booster record a dramatic close-up picture of separation, showing the second stage thrusting toward orbit. The last of the 1964 flights of the Saturn marked the 7th consecutive success for the 19-story high giant. But where do we go from here? To a place where once there was scrub palmetto and orange groves, until now. This is the Merritt Island launch area, where construction is underway to provide the huge facilities for the Saturn V. In this building, called the VAB, for Vehicle Assembly Building, the advanced Saturn, more than 30 stories tall, will be assembled. This structure will be the world's largest building in cubic volume. The Saturn V will be assembled on this launcher umbilical tower while inside the VAB. The launcher umbilical, Saturn V, and spacecraft will then be moved by a huge transporter along a 3.5-mile crawlway to the launch pad. From these rising forms of concrete and steel, man in his Apollo spacecraft will begin his space journey to the moon. During the year, 26 flights from the Cape were space missions involving satellites and basic research projects. These complicated space flights and those launched from the West Coast site at Vandenberg Air Force Base, California, have exceeded the geographic limits of a directional range. In a move to increase the effectiveness of global tracking, the Atlantic and Pacific missile ranges were linked together in January to form the National Range Division under the Air Force Systems Command. This National Range Division, commanded by Lieutenant General Leighton I. Davis, will wire the world for satellites. Major General Vincent G. Houston took over direction of the Atlantic link of the global operation when he assumed command of the Air Force Eastern Test Range, including Cape Kennedy Air Force Station, in August. Space communications links, infinite in the dimension of space, take on real meaning in projects like the Vela nuclear detection satellites. Scientists from the Atomic Energy Commission and Space Technology Laboratory designed and built a satellite system which could detect any nuclear explosion in space. The job to put this complicated system in orbit was assigned to a select crew headed by Major Jack Allen, a glider pilot in World War II and a graduate of the Air Force Institute of Technology. His chief of flight operations is Major Wally Munsey, who served double duty as guidance chief on Atlas-boosted space launches like the Mariner Venus probe. In July, the sharpshooting crew launched the Vela satellites into one of the most complicated orbital patterns to date. This military industry team includes veterans like Cal Fowler of General Dynamics, the Atlas test controller who launched the Mercury astronauts. This team's role in the Gemini program will be to place the Agena target vehicle into precise orbit for rendezvous. The Vela mission was unique. Place 3 satellites into orbit in one launch.
You're clear to launch. Thank you.
The payload included a small monitor satellite which was ejected into orbit at an altitude of 100 miles. 2 other satellites in the same payload were carried aloft to 55,000 miles and were placed into identical orbits but on opposite sides of the Earth. These satellites serve as electronic sentries in space. One basic research project is ASSET, a series of flights seeking solutions to the problems associated with re-entry into the atmosphere from space. Douglas-built Thor rockets hurl the ASSET spacecraft to altitudes of 40 miles, where hypersonic glides begin at speeds of 18,000 feet per second. ASSET transmits up to 138 different measurements to receiving stations along the range. McDonnell Aircraft builds the Delta Wing spacecraft of aerodynamic design, using a combination of metals, alloys, and new materials. The objective is to determine the best possible design and materials for a future spacecraft. Another global communications link was added on August 20th. Capitalizing on technology gained in the past, the National Space Agency launched the Syncom relay station into a circular orbit 22,300 miles above the Earth. After achieving orbit, Syncom began a series of intricate space maneuvers over the following 12 days to position itself precisely over the intersection of the equator and international dateline. Following the familiar gantry removal and last-minute preparations, the satellite was boosted aloft by a Thor Delta rocket with 3 solid fuel motors attached for additional liftoff power. With its altitude of 22,300 miles and a speed of 6,800 miles per hour, Syncom today orbits in perfect synchronization with the Earth. From this point, Syncom is able to transmit two-way telephone conversations as well as teletype and facsimile pictures. Live television transmission between Asia and America was an added bonus. By mid-1964 at Cape Kennedy, preparations were underway for the Ranger 7 mission. Man was aiming for his first clear, close-up look at the moon's surface, not through the lenses of a giant telescope, but as he would see it himself, just before setting foot on its surface. Ranger was a payload of complex electronic equipment and advanced design TV cameras. Its mission would be to photograph close-up pictures of the moon's surface right up to the instant of impact and transmit the pictures to receiving stations back on Earth. Enclosed in a protective shroud, fully prepared, Ranger took its last earthbound journey to the launch pad. There, the powerful Atlas Agena rocket waited for its payload to be installed. On the 28th of July, final preparations were made for the flight to the moon. The Ranger's target was the Sea of Clouds, an area on the lunar surface which would be studied as a possible astronaut landing site. As the countdown progressed, the faces of the men assigned to this incredible task reflect the anxiety associated with the final minutes of the launch operation.
5 seconds, mark. T-minus 5 seconds and holding momentarily. I have a commit arm light. T-minus 5 seconds and counting. Mark. Ignition start.
Ignition!
Lift off. Everything looks good.
Ranger 7, weighing more than 800 pounds with its 6 TV cameras, began the trip of nearly 250,000 miles to its moving target in space. About halfway to the moon, the Ranger, on a command signal from Earth, performed a planned maneuver and zeroed in on its course. Picture transmission began at an altitude of 1,120 miles above the lunar surface as the spacecraft approached the Sea of Clouds at a speed of over 4,000 miles an hour. These are actual photographs taken by Ranger. At an altitude of slightly more than 450 miles, craters of about 800 feet in diameter were clearly visible. At a distance of 35 miles, details never before obtained by telescope were easily distinguished. 3 miles above the Sea of Clouds, and less than 2.5 seconds before impact, Ranger revealed surface variations never known to exist. Photographing the moon from close range was a major achievement in the nation's space effort. The most critical technical challenges of landing a man on the moon still lie ahead. Thousands of skills are employed to bring the comprehensive effort together. The work in offices, research laboratories, in industry, military support, all contribute. At Cape Kennedy, there are sensational successes and frustrating setbacks. An automatic engine shutdown stopped the second Gemini flight attempt a split second before liftoff. A slight delay in the Gemini schedule. But in other programs, the launch tempo quickened. Minuteman. Titan. Centaur. Polaris. And at year's end, the Mariner 4, launched in late November, continued on its 350 million mile, 7.5-month journey toward the mysterious planet Mars. Like Mariner, the United States is moving toward distant but real goals in space. In 1964, significant progress was made toward those goals.